So let's summarize what we found. We found that if the derivative was negative, less than 0, then the original function was decreasing. If the derivative was positive, greater than 0, then the original function is increasing. If the derivative had a slope, if the derivative was equal to 0, if our tangent line had a slope of 0, then f had either a maximum or a minimum at that point. Okay, these were our extrema values. Okay, so taking that information that we just figured out, we have to do the first derivative test. Now, don't let that word freak you out. It's not a graded test. It's just what they call figuring out how to where a function is increasing or decreasing. So your steps are to find the first derivative. We're going to find where the derivative is equal to 0 and solve for x. This step is where we practiced last week. We're going to find any values where the derivative is undefined. We're not going to get to that this week yet, so don't have to worry about that. The x values from bullet 2 and bullet 3 are called critical numbers. So what you get from these two bullets are called the critical numbers. We're going to create a number line based on the critical numbers, and I'll show you how to do that. We're going to plug test values into the derivative on either side of the critical numbers and determine if the derivative is positive or negative. And I'll show you how to do that. A maximum occurs where the graph of f of x changes from increasing to decreasing. So think about that. If your graph is increasing and then it's decreasing, we have a maximum. And a minimum occurs when the graph changes from decreasing to increasing. So if we're decreasing then increasing, then this guy is a minimum. Okay, so let's do an example here. Given the function f of x equals x squared minus 4x plus 3, we're going to find the intervals, I spelled that wrong, intervals, on which f of x is increasing and decreasing, and we're going to find the x-coordinate of the local extrema. Okay, so the very first step said to find the first derivative of f of x, or find the first derivative of f prime of x. So f prime of x is equal to 2x minus 4. Okay, fairly painless. The second thing we're going to do is we're going to set the derivative equal to 0 and solve for x. So I'm going to take that derivative, 2x minus 4, and I'm going to set it equal to 0. I'm going to solve for x. So I'll add 4 to both sides. 2x is equal to 4, and dividing by 2 gives me x equals 2. This is a critical number. I like to abbreviate it as CN. There is no place where this derivative is undefined, so we don't have to worry about that. Okay, so the next thing we want to do is create a number line. And we only have one critical number, so I'm going to put 2 on that number line. And I always like to label the beginning of the number line with the derivative because I'm going to plug numbers into the derivative. Okay, so we have to test on either side of the critical numbers. So what that means is we have to test a number to the left of 2, and we have to test a number to the right of 2. So I want you to think about a number that's to the left of 2. Most people say 0, and we're going to test it into the first derivative. I'm going to put that 0 into the first derivative. So that gives me 2 times 0 minus 4. And here's the kicker. I don't really care what that actual answer is. I just want to know if it's positive or negative. So 2 times 0 minus 4 is going to give me a negative number. So it's less than 0. So I'm going to put a little negative sign here. That means that any number I test to the left of 2 is going to give me a negative value in the derivative. Now I got to do the other side of 2. So give me a number that's bigger than 2. All right, 3. We're going to test it into the derivative. So 2 times 3 minus 4. Again, I don't really care what the actual answer is. I just need to know if it's positive or negative. So that is a positive number. It's greater than 0, so I'm going to put a plus sign here. So let's think about what this tells me. This tells me if my derivative is negative to the left of 2, that tells me that the original function is decreasing on the interval negative infinity to positive 2 because the derivative is negative. If the derivative is negative, the original function is increasing, right? If the derivative is negative, then the original function is decreasing. Did I say increasing? I meant decreasing. And then this tells me that f of x is increasing. Oops, my computers want to sleep here. Increasing. on the interval 2 to infinity because the first derivative is positive from 2 to infinity. Now, oh, I'm sorry, we have one more thing to do. This x equals 2 is an extremum. The graph of f changes from decreasing to increasing. So if it changes from decreasing to increasing, that makes it a minimum. So x equals 2 is a relative minimum. Now you may be saying, well, Mrs. Fulmer, what happens if you have more than one critical number? So you would end up with something like looks like this. Let's say we had critical numbers of x equals 2 and 5. You would do the same thing. You would make your number line, but this time you would have x equals 2 and x equals 5, and you would have to test 3 numbers. You'd have to test a number to the left of 2. You would have to test a number between 2 and 5, and you would have to test a number to the right of 5. Okay? So that's what you are going to be doing on these 3 problems. You are going to be taking the derivative, setting equal to 0, solving for x to find the critical numbers, and then doing a number line test. Take the derivative. This one is probably the easiest one here. It's just like the example I just gave you. And this one is probably the hardest one. So I would actually go in this order. I would go 3, 2, and then 4. Okay? If you have any trouble, send me a message and I'll do what I can to help you.